All right, so let's start trying to take the limit, because in general, that's what you do when you're trying to find out if a sequence converges or diverges. Sine of infinity, that's dne. 3 to the infinity, that's infinity. dne over infinity, that is not an answer. You can't use L'Hopital's on it, so something else must be done. Squeeze theorem. So when you take a limit and you get something like this, that's when you know you need to go back and start from the drawing board and do squeeze theorem. So squeeze theorem, remember you had to have two inequalities. So sine I know is bounded between 1 and -1. Then I would divide everywhere by 3 to the n. And then I would show that if I take the limit as n goes to infinity of this one, here I would get -1 over infinity, so that's 0. And if I take the limit as n goes to infinity of the right-hand side, I get 1 over infinity, that's 0. So therefore, I know that this will converge to 0 also by squeeze theorem. So remember, there were several things you needed to show. So you needed to have this inequality set up with both sides. You needed to have the limits of the two outside functions. Then you could make the conclusion, and you had to say what it converges to, and then by squeeze theorem. So same thing with this one. If we were just to start doing it, I would get dne over infinity. That's bad. So I'd say, okay, let's start off with a true fact I know about cosine squared to bound it on both sides. So I know it's smaller than or equal to 1. And since it's cosine squared, it's bounded on the other side by 0. So now I'm going to divide through by n cubed. So 0 divided by n cubed is still 0. Divide by n cubed, divide by n cubed. Okay, so that's my first of my several things I need to do. So limit as n goes to infinity of 0, well, that's 0. N goes to infinity of 1 over n cubed, right? I'm taking the limit of the two outside terms, and that's 0. So therefore, the one in the middle, this sequence, converges to 0 also by the squeeze theorem. So all of this is necessary for the solution. Okay, so the last of the types, so when it's alternating, so when I have a -1 to the n, or a -1 to the n minus 1, or a -1 to the n plus 1, times your a sub n. So that would be times the positive part. So what will happen is if the positive part has a limit of 0, then I say the whole thing converges to 0. If the positive part does not go to 0, then the whole thing diverges. Okay, so let's just take a look at some of these. So this right here is the a sub n, right? So what I'm being told to do is take the limit as n goes to infinity of the a sub n. Notice there's no -1 to the n in the limit. That's a really big deal. You can't take a limit with a -1 switching. So there's no -1 in there. Big deal. So if I take the limit of this, taking highest powers, I get n over n squared, cancel, I get 1 over n, the limit is 0. So that gets us to this situation. So therefore, I know that this converges to 0. And I'm going to say by this ASR, alternating series rule. So to get a picture of what this is, plug in n equal 1 and 2 and 3 and 4, and as time goes on. So if I plug in n equal 1, I get n equal 1, it's a negative term, and then a positive term, and a negative term, and it's positive. So it's changing sign, but as it's changing sign, it's getting closer and closer to 0 because the terms, the positive terms, are getting closer and closer to 0. So that's why it converges to 0. Let's look at this next one. Again, I see it's alternating, so I'm going to take the limit as n goes to infinity of just the positive part. Highest power, since I'm doing limits with infinity, I just get 1. Okay, so let's think about this. This is limit as n goes to infinity does not equal 0. So this gives me the conclusion this diverges by ASR, the alternating sequence rule. So let's think about what's happening. 1, 2, 3, 4. As the numbers are getting larger, the positive part's getting closer and closer to 1. And so when I plug in n equal 1, I get a negative, and then it's a positive, and it's a negative, and it's a positive. And as time goes on, they're getting closer and closer to 1, and they're going to oscillate between 1 and negative 1. So that's what it looks like as it diverges. About this one. So again, it's alternating. So I just take the limit of the positive part. And the positive part, if I put in infinity, 3 over infinity is 0. Sine of 0 is 0. So this converges by the alternating sequence rule. Okay, so the next section we move into infinite sums, which are called series, where I was showing you how you could draw a sequence. We cannot draw a sum, because that's like saying add this and then put this on top of the pile and this on top and this on top and this on top. And we're going to look to see if it converges or diverges, and we're going to have tests. We'll have tests on these series. Okay, we had one section on sequences. So this is a minor topic. These series, we're going to have 6 sections. So this is a major topic. So make sure you're keeping in mind that this is minor. These are rules that don't get used very often. These series, as we turn the corner, are going to be much more challenging, and we're going to learn all kinds of tests to use on how to look at an infinite sum.